Yes, ma'am.
Okay. See, one topic is left from your rotational, that is rolling motion. All right. So let's complete this. Then we have gravitation left from our first book. Class, for the second book, I was planning that, see, if we take extra classes for the thermal physics portion, so that in this regular timings, we'll be doing gravitation, mechanical properties of solids, then mechanical properties of fluids, because fluids is also a very lengthy lesson. And then your thermal physics portion, thermodynamics and thermal physics and all, that will be dealt separately. Right. I think that is better. You will make a separate notebook also, and your syllabus will be completed on time. Because even after completion of thermal physics, we'll be having SHM and waves left. 11th class syllabus is very lengthy, you all know. So for that, I was planning that if we have extra classes, but I'll just check up your schedules because you have other classes also. No, Leena, I think you have maths class on Wednesday. Some of you have chemistry classes. I'll just check up with the schedule of all, then I'll let you know. All right. Otherwise, some Fridays we'll be needing, because see, right now I wanted to take extra class last week only, and this week only. I think next week you'll be having holidays also. See, for rolling motion, my voice is audible. Just wait. Yes, now my voice is fine. The connectivity is better now. It's fine. Okay.
Yes, ma'am.
Okay. Now see, in rolling motion, basically what happens, rolling motion is a, okay, Mariam. Okay, okay. Fine, it will just take 5 to 10 minutes. I'm not also even going into the details because many things have been deleted. The rolling motion and all. I'm just telling you superficially. Don't worry. We'll not be even studying it in detail, because that is, I think, not just deleted for you. I think it's deleted from CBSE syllabus also. Others also, what is the status of rolling motion in your school? Deleted or still there? Just update me. Mariam has updated me. Anyone else? Khadija, Lina, because in school this chapter must have been over. Nuha, rolling motion is there or not? Can you just check and let me know? Okay. Anyways, in rolling motion, we basically have the center of masses. See, when I say a wheel is there, suppose. So I have taken 3 points at the wheel. Suppose this is the wheel. I have taken 3 points at the wheel. 1, 2 in the middle, and 1 at the lowermost part. So see, the center of mass must be moving ahead. This is the velocity of center of mass. This is the velocity of center of mass. This is the velocity of center of mass. So when the center of mass is moving forward, when the object is moving forward like this motion, this is known as translation, which you have been studying. Translation. Secondly, if I say instead of moving like this, I'm saying a particular body is moving like this. See, where with which the point it had started, this point is now coming downwards. Now this point is coming upwards. Then again, this point is coming downwards. This is known as rotation, which you have studied. So in rotation, what happens? There's a fixed axis with a certain separation, and the velocity's formula is omega into r, and this actually rotates. There is rotation that occurs, and the velocity is tangential, whose formula is r omega. This rotation part you have studied in this list. Now see, when rotation plus translation, they combine with each other, then we get the motion which is known as the rolling motion. Suppose this was the motion, this was translation, this was rotation, right? So rolling is rotating also and translating also, like this. This is rotating also and translating also. This motion is known as rolling motion. All right. So this rotates with certain velocity omega. Just a second. and this center of mass VCM will be moving further. So this will be translating, this will be rotating. So this combined motion is rolling. So when you have to tell the net velocity at the periphery, if I say at this A point, you will tell the net velocity will be at A point will be R omega plus VCM. At the bottom, if I ask you about it, it will be, you will subtract now VCM minus R omega, because see both have this different directions. Like this is what you have to remember about rolling motion. Objects move. Similar, same thing will occur with acceleration also. If I'm talking about this acceleration, same thing. ACM, then acceleration. Remember when we were doing circular motion, that time we specifically did this, that centripetal acceleration is coming, and then tangential acceleration is alpha r. So here tangential acceleration will come, and likewise you will have the same thing which is occurring in acceleration. This is what you have to remember. One more thing, let me discuss. See, pure rolling, meaning of pure rolling. Pure rolling means the translational component is greater than, is equal to the rotational component. Means you can have component where the rotation is more and translation is less. I'll tell you, see, it can happen that in the first case, rotation is more than translation. Rotation is more than translation means a slight translation, but rotation is more. A very slight translation, but rotation is more. See, if the tires get stuck in the sand, they are not able to move, they are not able to translate more, but the rotation is very fast. So rotation component is there. This one example is if tires are stuck in the, this is sand, in the sand. Second component. See, if translation is greater than rotation. This was rotation greater than translation if translation is greater than rotation component. Like, see, when there's a very smooth road or ice, surfaces like ice. So what happens? There the tires are not rotating, rather they are skidding, which we see, no, the tires are sliding. So in that case, translation component is more than rotation. Rotation is there. Tires are also rotating. They are rolling also. They are rolling. But in rolling, rotation is less. This is the case. Like this. This. In the first example, it was more like this. That's it. Slight translation, more rotation. Second case, more translation, less rotation. So example is, if tires are sliding. Fine. But if both the components are same, translation is equal to rotation. It means if I say a particular wheel or something is rotating, this distance covered, let's say this is 5 meters. This rotation covered, this is entirely 5 meters. And translation covered is also 5 meters. Means translational component is equal to rotational component. Rotation is also 5 meters. This distance covered is also 5 meters. So this is what you call as pure rolling. The distance covered in translation and distance covered in rotation both are equal in pure rolling. All right, these are some points which you have to remember. Quickly write down in your registers also after radius of gyration. Write it from here. And please, nobody confirmed me about their schools about rolling motion. Is it included or not? Hudeja, I think, has lately done. Yes, Noha?
No, ma'am, it's not included.
It's not included, no. It's actually deleted from CBSE syllabus. Okay. That's why we won't be even practicing numericals. We'll straight away start with now gravitation. But it's just that, no, when we'll be doing fluids, when we'll be doing waves, there that time you'll be needing rolling motion, a bit concept of rolling motion, not in detail. So that's why an overview, you also write it quickly, make points. This much is sufficient. Yes, class. So chapter 8, this is the last lesson of your first book. See, we'll be talking about two things, Newton's laws of gravitation and Einstein's theory of gravity. First, we'll focus on Newton's laws of gravitation. So, because class, one more thing I'll tell you, in class 12th, when you will go, you have a lesson, the first lesson that you'll be studying in another few months is electrostatics. So whatever things you will be studying in this lesson about masses, like M1, M2, two masses are there. And the way a force is also present, a formula is there, Newton's law is there, potential will come, gravitational energy will come. Same things will be there for charges in electrostatics when you will reach class 12th. So like M1, M2, you will have Q1, Q2. Instead of Newton's law, there is Coulomb's law, very much similar to this law. The constants are different. Gravitational energy here, electric potential energy there. Like this, you will be having everything similar. Whatever you study in gravitation is exactly the same, right? So just pay attention in this for this lesson, and keep it in mind that you have to understand and learn a similar topic in 12th also. So if you study it here, well, some things are very different, but most of the things are similar, like basics of energies, basics of formula. So let's start with Newton's law of gravitation. Newton basically said that, see, if two masses are present, suppose these two masses are present. Now they have their mass, let's say this is some in some grams, this is in some grams, and they are separated by separation, a small separation. So Newton's law says that the gravitational force in between them. Gravitational force is what? Gravitation, pull. So the pulling force between the two masses, or the forces that they are exerting on themselves, on each other. M1 is exerting on M2, M2 is exerting on M1. So the gravitational force which they are exerting between them, this is directly proportional to two things you have to know. First, M1 into M2's magnitude means mass 1 is there. See, mass cannot be negative, so magnitude concept here is not applicable. Masses will always be either be 0 or it will be positive, correct? So product of masses, like if I say first mass is 5 kg, second mass is 2 kg, so force is directly proportional to 10. 5 into 2 force. This is the first point which you have to remember, right? So M1 into M2, this is the gravitational directly proportional to. So this is M1 multiplied to M2. So directly proportional to product of masses. Second point is that their separation is there. I have taken it as R in this figure. So it is inversely proportional to the square of this. So 1 by R square, inversely proportional to the square of distance between them. Now, when I'll combine this, Fg, that is gravitational force, it is proportional to M1 into M2 by R square, right? So in mathematics, whenever we have to remove the proportionality sign, what do? We put an equal to with a constant. So gravitational force will be equal to constant. Now here I'll directly write down the constant. The constant that we use here is capital G, not K. I'll directly use G. M1 into M2 divided by R squared. Fine. This G is the universal gravitational constant. This is very unique here because this is found only in Newton's law. I told you, you'll be studying electrostatics also. There also constants are different for different materials, for different medium. The values of constants are different. But here you have the value exactly the same. Take two masses in air, calculate the gravitational force between them. Let's say it is coming 3 Newton. Now I'm taking both the masses and I'm dipping them in water. Now I'll calculate the gravitational force. It will still come 3 Newton. I'll take it, I'll dip it into oil. It will still come 3 Newton because gravitational constant is universal. Universal means with respect to medium, it's not changing. Its value is fixed. See, the value of gravitational constant, this will be everywhere. It will be 6.67 into 10 to the power minus 11 Newton meter square by kg square, right? This will be the unit. And this value, class, you have to remember because this is like the value of a constant, which it's like speed of light. Speed of light you all have to remember, which is 3 into 10 to the power 8. Those who don't know, you have to remember certain values which will not be mentioned to you. So these value you have to remember, 6.67 into 10 to the power minus 11. In maximum chances are there that in the questions it's not mentioned, because this is something which you have to remember. So it's valid only for point masses or spherical bodies. Fine. This point is clear. F is equal to G m1 m2 by r square. That is Newton's law of gravitation, is valid only for point masses or spherical bodies. Fine. Second point is that gravitational forces are conservative force. Conservative forces, non-conservative forces we have studied. If you remember, conservative forces were the forces which were just depending upon the path. They were just depending upon the initial and final position. They don't depend upon the path you travel, whether you go straight, whether you take the body up and then reach the final position. They are just concerned with initial and final. Whereas non-conservative forces like frictional forces, these are dissipative forces which produce heat in your system. All right, write this force down, then we'll practice question. But is the law clear to you? Yes, Mariam. What was the first statement of Newton's law? Mariam. 2 points I told you. Gravitational force is proportional to 2 things. Just tell me one, Maria.
The mass.
Which mass? One mass.
The
If I say m1 and m2, 2 masses are there, then two masses are there, Mariam.
yes, ma'am.
Right? M1 is one mass, M2 is another mass. 2 masses I'm telling you. So first point which you are saying, it is directly proportional to mass. So it's proportional to which mass? M1
Mass
or
of
M2?
the
It's written. See, the formula is written on the screen. I have not removed it. What do you think it's written? See, M1 into M2. Product of masses, no?
product of mass.
Okay, Mariam. See, when I say when the first law, when M1 into M2 is written, it basically means that M1 mass is there, M2 mass is there. It will be having some value, it will also be having some value. So which will you consider? Whether you will consider M1, M2? No. Both the masses with their product. Like if one is 5 kg, second one is also 5 kg, 25 you will write. Okay, clear?
Okay.
First point?
Yes, ma'am.
Okay. Yes, Khadija. Second point. That was the first point. Second point, Khadija. Yes, Khadija, say. Khadija, answer. Do you know?
I don't remember.
Don't remember. Nuha, can you help us?
It is inversely proportional to the square of the distance between the two masses.
Perfect. Perfect. See, Khadija, do you see this r square in the denominator?
Yes.
So it means this is inversely proportional because it is coming in the denominator. And square is also there. So gravitational force is inversely proportional to square of separation between them. So Khadija, Mariam, Nuha have helped us revise. So I hope now you all remember what is the Newton's law. F is directly proportional to product of masses and inversely proportional to square of distance between them. This point, this is also known as that this follows inverse square rule. This follows inverse square rule. That is also sometimes stated. Write it down, then we'll practice questions from this. And please make a separate, start from a fresh page. Don't start it from wherever you have left rolling motion. Like, look at this question class. 5 kg mass is given, 10 kg, separated by 10 meters. So what is the force? G m1 into m2 divided by r square. So value of G 6.67 into 10 to the power minus 11. M1 5 kg, M2 10 kgs, and R square, that is 10 into 10. So 10 10 will be cancelled. 5 to 3.3 to 5 into 3.30. Let's take it. 10 to the power minus 11 Newton. All right, like this you have to solve questions. Okay, let's start with gravity. Write down this quickly, then we'll start with acceleration due to gravity. So see, now talking about gravity, gravitational pull of Earth is known as gravity. See, gravitational force is existing everywhere. It's universal. That also I've discussed with you. So gravitational pull of Earth particularly is called gravity. That gravitational force which is occurring, that is F is equal to G m1 into m2 divided by r square, specifically for the planet Earth, that is known as gravity. Fine, this is a term gravity for it. See, acceleration, if I say this, I'm talking about Earth. Suppose m mass is there, r is the radius, and I have one more object, let's say, whose mass is small m, and I want to find out the gravitational force. So see, I will be writing down the formula as G, mass is 1 is Earth's mass, right, capital M. Second mass is of the body, small m, divided by r squared. That's it. That's how we use the formula. Now see, if I have to find out the acceleration, that is acting because of this gravity. Acceleration which is occurring because of this gravity. You are already familiar with this gravity in motion in a straight line, motion under gravity. We have used it so many times, multiple times we have used acceleration due to gravity. You know the formula also, and we have been using it. So this is force divided by mass. What is the force? Force is G, capital M, small m, divided by r squared. This is the force, and here is m. So mass gets cancelled. G is equal to G, capital M, by R squared. Fine. Now see, what all things? Small g is the acceleration due to gravity. This is the acceleration due to gravity. G is the universal constant. This is universal constant, 6.67 into 10 to the power minus 11. This is the mass of Earth. This is the mass of Earth. 6 into 10 to the power 24 kg. And this is the radius of Earth. Which value you will be using? 6 into 10 to the power 6. Fine. This value you will be using. Also, the value of acceleration due to gravity, particularly for Earth. This value, when we are talking, when all these values were put, radius of Earth was put, mass of Earth was put, G is put. When you will calculate it, you will see G's value is coming 9.8 meter per second square, which we have been using already, right? This is nothing new. Different things we will be studying here, not the usage of this. You know the usage of it. And also, you also know that sometimes acceleration due to gravity is equated and written as 10 meter square also. Fine. So this you can see, this is independent of mass of body, because see, small m is not coming anywhere. G into capital M by r square, mass of Earth, radius of Earth, and universal constant. So whatever is the body, small m is not included anywhere. So it means whatever be the mass, whatever be the shape, whatever be the size of that object, G will remain 9.8 meter per second square. Fine, write it down. Now class, superposition principle. Superposition principle, it's a principle not just for gravitational lesson. Fine. This is not just for the gravitational lesson. It's a principle. So it will be applied in different areas of physics. I have already mentioned and told you that this will come again in class 12th also, but not just in electrostatics, in other lessons also. This principle is valid for vector quantities and it will come ahead also in 11th also. So it's a principle. So this principle basically says that when you have n number of vectors, when you have to find out the net, you will take their sum. If it's a scalar quantity, you will add it algebraically. If it's a vector quantity, you will add it vectorically. So here, force is a vector or a scalar? Vector or a scalar?
Vector.
Vector, no, correct. So force is a vector quantity. So suppose I have m1 mass and m0 mass is fixed. The other mass is m1. Then one more mass I have taken m2. One more m3, m4, m5, m6, up till mnth. Nth I have taken mn. Now, n number of masses are there and I want to find out the net force. So what will I do? Superposition principle basically says that this is valid for two or more point masses. It says that first calculate their individual forces. This force. Then calculate this force. Then calculate this force. Like this, calculate all the individual forces and then add them vectorically. Vector laws, you know, you have to use parallelogram law. You have to use triangle law. Correct. So net force, how will you write the net force? Net force will be like F01 plus F02. This is not algebraically adding like 5 Newton and 6 Newton. You will add and say 11 Newton. No, you know, if 5 Newton and 6 Newton both are present and their angle is, let's say, 90 degrees. So it will be under root 6 square plus 5 square, not 11. So vectors you already know till nth. So for a system of n interacting point masses, the net force on a given mass is vector sum of forces due to individual mass. Like I'll give you an example. And again, I'll tell you, this will come in 12th also in detail. You have there in 12th various portions. In 11, you have very less portion of superposition. Like this, a mass is given at the center, capital M. And here you have point masses small m, small m, small m. And you have to find out the net force at the centroid, means at this point m. So now not only one force is there. If I say force at A, it will be capital G. First mass is m, force between these two. Second mass is small m. What is their separation? R square. So I'll say FA is this. Come to FB. Come to the forces between them. It will also be G capital M small m by R square. Come to the third one, C. FC will be G capital M small m by R square. Instead of writing them separately, I am writing each one as F because their magnitudes are same. It will be helpful in calculation. Fine. Now these are the individual forces, 3 separate individual forces. Now I have to add them vectorically. So I cannot add them straight away and I'll say answer is 3F. That is FA plus FB plus FC. So F plus F plus F. 3F is the answer. That is 3GMM by R square. No. Because this is not algebraic addition. Algebraic addition is not required. I have to add them vectorically. Correct. So for vector addition, we have to obey the vector laws. Now see, parallelogram law is valid only for 2 vectors. This we know. So see, suppose this was the force first. And this is one force acting. This is one force acting. This is the case. Till here, is it clear or not? Clear?
Yes, ma'am.
Yes.
Okay. So see, entire angle is 360 degree. 360 degree divided into 3 parts. So each will be 120 degree. At least we can solve these 2 forces first. If you complete the parallelogram, the resultant would be of these 2 would be somewhere here, right? F dash. Let's find out what is the value of F dash. F dash will be under root F1 square, so F square, F2 square, F square plus 2f1 into f2 into angle that is cos 120 degree. So this becomes 2f square plus 2f square into cos 120 is minus half. So 2 gets cancelled. See, 2f square minus, because of this minus f square. This becomes under root f square, which is equal to f. It means their resultant is also coming f. Class, one force is here. One force is exactly acting in the opposite direction. Can anyone tell me what is the net force now? One force is acting, F is acting upwards, F is acting downwards.
0.
0. Very good, Mari. Because both are making an angle of 180 degree. They'll simply cancel each other. You'll subtract these two vectors. They are making angle 180 degree. Net answer, net force is 0. So see how superposition principle changed your answer. Otherwise, our answer would have been 3 times F. We would have just added them. So answer this is the net force is 0. Write down the superposition principle with this question. Yes, class. So see those